What, man?
I think y'all.
Oh, but you cheating on me, bro. I just found it out, bro.
I think you're she was like that. Like doing it. Her, somebody, and we thought.
BRA and deal on
Where's she at? Might be.
I said BRA.
So, apparently 1.2 we don't need to talk about very much. 1.1 it looks like most of us are okay. I'm thinking 1.3, 1.5. No, I'm not doing all of them, Terrence. There's this weird thing where I already taught it. I'll pick a few of these to go over. 1.8 and 1.10 for now. I mean, the fact that I have 20 some odd students and the most anyone indicated was 12 on 1.3, 1.5, it's not terrible. For the most part, we should know how to do this. Now, I do want to remind you, you can always graph these transformations. It will take more time, it will take more energy, but you can't always do that. I explicitly told you when we were going through the task and the lessons that you needed to learn how to work with the mathematical operations as well. And so you cannot earn 5s and up on the rubric if you don't follow that idea of indicating the mathematical operations, because they should make sense. We went over them for a reason. So these are the problems we look at. We may look at 1.6 and 1.7, and then we will get back to the review packet today. So we were good there. So I assumed 1.3 and 1.4, 1.3 for sure. So a couple of quick things. I'm going to reference back to the graph to make this make sense. But there's a very simple way to do a 180-degree rotation. So first off, we have -3. 1, 2, 3, 4, 5, 6, 7. There it is. If it is a clockwise rotation, is it going towards quadrant 1 or towards quadrant 3?
Towards quadrant 1.
Quadrant 1. Remember, it is following a clock. That is clockwise. Clockwise means it is following the order of a clock. That's it. So if I'm here and I'm going clockwise, it's going into quadrant 1. The most basic principle that we talked about with a rotation, and so even if you were to try to graph this, you had to remember this rule. What happens when you do a 90-degree rotation?
X and Y switch.
The X and Y switch, right? So it was -3, 7, so it becomes 7 and then a 3. But looking at the quadrant it's in, are any of those numbers negative?
No.
No. That's the plainest thing to notice, is that when it is a 90-degree rotation, all it's going to do is the X and Y are going to switch. You have to know what quadrant it's in, determine if it's positive or negative. By the way, I'm directly going over one of these problems that a whole bunch of us indicated we were having trouble with, so maybe you take down some notes. You could have drawn this out to help you get started. Now, am I done?
I have a question.
Say again, Kelsey?
It's not, wait, oh, but it's not 93, it's 180.
Correct. I'm not done yet. That's why I just said, am I done yet?
Oh, no.
No. I need another 90-degree rotation, right?
Mm-hmm.
So, I'm now quadrant 1. What quadrant will I end in?
4.
2.
Going here to 4. Remember, I started in 1. Then I went to quadrant 1. Now I'm going to quadrant 4. And what's going to happen to my X and Y again? They don't say flip.
Switch.
They switch, right? Remember, flip kind of ties into the idea of a reflection. So instead of being 7, 3, it's going to go back to being a 3 and then a 7. 1, 2, 3, and then down 1, 2, 3, 4, 5, 6, 7.
3 negative.
So it'd be 3, negative 7. You don't have to memorize whether it becomes positive or negative. You just look at the quadrant. It's to the right 3 and down 7. To the right 3 is positive, down 7 is negative. Alright? So, I will point this out. I will point this out though. It went from a negative 3, 7 to a 3, negative 7. When it's a 180-degree rotation, and we talked about this in class, what can you do with a 180-degree rotation instead of having to go through both of those steps?
Bam. My bad.
Say it again. Was it just a negative on the y?
And they just switch the opposite of the y.
Just the y? Just the opposite of the y?
Yeah.
I think it was the opposite of the x too,
I
wasn't
don't
it?
know.
I mean, look
Oh, I
at
didn't see.
it. Negative 3 to 3, is that the opposite?
Yes.
So, the rotation of 180 degrees, whether it's clockwise or counterclockwise, because remember those are equivalent, that should be super easy. Both the x and y become opposite. That every time it's a 180-degree rotation, and this is why it's easier to learn the formulas and the rules sometimes. That's really easy to just take the opposite of my x and y. If it's a 180-degree rotation, it's the opposite of the x and y. See, these are things that we could be writing down to learn.
I don't listen to what you're saying.
Oh, you weren't? You were daydreaming.
No way.
Stop.
How you gonna say? Stop.
What did you say? What did you say? 180 degrees?
Both the x and y become the opposite.
Oh.
Sir?
This ain't mine. This was already in there.
Just leave it under the desk then. No. Okay. And so that is a lot less work, and I want you to notice, if I draw a line from here to here, and then I continue that line to 3, negative 7, what kind of angle does that create? It creates a straight angle, or what measure? 180 degrees, right? Because it should create a 180-degree angle. Notice if I put a line out to here, I'm creating what kind of angles? 90-degree angles, right? And that is again the point, that we are creating those perpendicular line segments. That's how we know it's a 90-degree angle. And so that's when the x and y switch, and so on and so forth. And so instead of going through all of that work, if I know it's only a 90-degree rotation, what do I know is going to happen with my x and y?
Swap.
They switch, right? Or swap. So instead of being 4, negative 2, it's going to be a 2 and a 4. That, and I'm not done yet, but that's the biggest thing. If it's a 90-degree rotation, I know my x and y swap, or they switch. The only thing I have to figure out now is whether they're positive or negative, which that's all about knowing what quadrant it's in. 4, negative 2, that's to the right 4 and down 2. Notice, did I even put any tick marks on this graph?
No.
Just went to the right 4, down 2. I know that's where it is. If it's a counterclockwise rotation, is that going to go into quadrant 3 or quadrant 1?
Quadrant 3.
One.
So this
One.
is a counterclockwise rotation?
Oh, no, quadrant 1, my bad, I didn't see that.
And that's why, like, if you need to, draw out the arrow, but when you draw that, you should see, hey, that's the direction of a clock. That is clockwise. We want counterclockwise, so it goes into quadrant 1. So are the x values positive or negative in this quadrant?
Positive.
Y values positive or negative?
Negative.
Positive.
So it's 2, 4, I'm done. Like, all you have to do in that problem is indicate, to earn full credit, based on what mathematical rules are at play, the x and y switch, with a 90-degree rotation, and the point ends in quadrant 1, so both are positive. It's just putting language to what was happening, to what you know. That's all it is. And Kaylin, that's the justification I've been asking for all year, is that we explain how we get our answers. The rubric that I gave you all at the very beginning of this semester very clearly requires justification every single time. You get an answer correct with no justification, you're earning a 3 out of the 6 possible. Huh? No. Been over that rubric multiple times this year. Yes,
I
sir.
can't see.
You can't see? Well, then jump up here to group 1 and take some notes.
I can copy off the
I'm not saying stay up here permanently. She kind of needs her paper.
She got
You can come up here while we go over the understanding check to take notes. I wasn't even supposed to do 1.4. Well, y'all get a bonus.
Christian. My number 5.
We're not quite at 5. Hold on a second. Does anybody want to ask or need to ask a question about 1.3 or 1.4? You're not. Which phone? Which pocket number? It's 7.
Yeah.
Alright,
It's not much fun.
so Matthew, you had a question about 1.5?
Yeah, so I did everything you asked on the question and I still got a 5.
You tripping? I'm gonna follow. Do that.
Okay, but if
I
you
know.
did everything, you would want a 6 too.
Yeah.
Thank you. If you did everything, who's just went off then?
No, but my phone doesn't have that setting.
Gotcha. So if you did everything, you would have earned a 6.
Yes.
Tell me what you did.
So, you might want to come and see this.
Talk me through it.
So, I put down the coordinates that I could, the points that I got for the pre-image. No, the image.
Well,
the
the
image.
pre-image is already here, so
The
what
image.
points did you get for the image?
-3 and -2.
So -3, -2 would be
Yeah,
here.
for
So, got that point, what's the next point?
1, 0.
Okay, so this point here,
Yep. And then 5, -3.
5, -3 would be here,
Yep.
alright?
And then
Is there anything I'm missing right now?
yeah. So I put the I substituted the points that I got into the x minus 3 and y plus 2.
But is there anything I'm missing right now?
The line.
Connect to that?
Yeah,
So I need to connect the lines,
Yeah.
okay?
Okay.
Quit, just quit.
But for each point, you put the
Yes.
x and the y value into that equation.
I'm actually not completely correct up to this point. Hey, group 3, why are y'all talking?
Oh, you gotta label them.
Thank you. Label both transformed triangles. What is this point right here?
A prime.
A prime. What is this point over here?
B prime.
B prime. And this one?
B prime.
Yeah, I did that too.
Okay?
And then I started to do the points for all the images, and then I substituted into the x minus 3 and y plus 2.
So like,
That makes sense?
now let me ask you a question. Did you actually show me the work?
Yes.
You never told me how you got these.
Yeah, but look, and I put it before.
But you never told me that how you got these. I needed you to tell me, hey, I got the opposite of the y values. That's it. Literally, I circled it and said, how'd you get these? What do you think? What do you think I meant by that? That might have been a 5.5, Matthew, looking at it again, but that's definitely not a 6 because you didn't justify that element of it. But a 5 is also a really strong score. Remember, what average score do you need in order to earn 100?
5.
Not 5. 4. Not a 4.
2.
You're just shouting stuff at this point. It was a 5.5 average is 100.
So it's 2. So it's a 5.
No,
Please stop. No, it's not, because a 3 is a 3 out of 6. Remember, a 5.5 average is what I consider 100. Typically, what I do is I consider a 2.5 a 70, and I use a linear interpolation is what it's called to figure out the rest of the points, or figure out your score. So like, if a 5.5 is over here, and that's a 100, and a 2.5 is here, and I consider that a 70, then I have those 2 points, and I'm able to figure out the rest of the score. So like, if you score an average of 2, whatever this is your score. If you average a 4, then whatever this is your score. Right, so I use that linear a line to figure out those scores based on your averages. Okay? So I will point out, you're not done at this point. Well, first off, we haven't done the second transformation, but beyond that, you have to justify it somehow. So just saying, hey, the opposite, right? So it's a reflection across the x-axis. So x values stay the same. But opposite of y values. That would justify how you're getting those points. And mathematically that could be a 6. If you wanted to, what you could do is you could show the reflection like this. That won't quite earn you a 6, but graphically, remember, the distance from one side to the other stays the same. I will point out, because this is a detail that caught a lot of us off guard, if I'm reflecting across the x-axis, but this point is on the x-axis, it doesn't go anywhere. If you're going to put B prime here, what you're saying is that B was up here. It wasn't. Remember, if you have 1, 0, and you get the opposite of y, well, that's still 1, 0. So for those of us who got the wrong B prime because we didn't realize that it's on the x-axis, so it's not going to move, that's why, right? The opposite of the y value is still 0. Now, Matthew, I will say you made your life harder than it had to be here. All you had to say, instead of showing me every single point in that subtraction, is just subtract 3 from x. You could have done that and shown me 1, 2, 3, and then we're going to add 2 to y. So it goes up to there. So there's A. What symbols would I put on that A?
The 2 things on it.
What do we call that?
Prime.
Not prime. Double prime. Remember, A prime was here. I did a second transformation, so this would be A double prime. And there's B double prime. And there's C triple, or double prime. And so there's my triangle.
Yeah, I did that too.
Do you have a question about that, Ari? Okay. Anybody else have a question before I move on?
I just got I've got to do the first one.
You probably do the first triangle?
Yeah, I did little arrows and pointed down and show where it went, but
Gotcha. Alright. Any questions about the reflection or the translation before I move to 1.6?
I think I'm ready.
Yes, ma'am. Hold on, I'm sorry, I can't hear Ari because there's a whole bunch of people talking when she's probably asking a question that you might need to hear. Can you say that one more time?
Where do you subtract 3 and plus 2?
Subtract 3 from every x, right?
So you do it for all of them?
Right, because the entire triangle A prime, B prime, C prime is translated by this. So this was the point -3 comma -2. So I subtract 3 from the x, that gives me -6. And I add 2 to the y, which gives me 0. That's this point. Right? You do the same thing with this point, subtract 3 from the x, add 2 to the y. Subtract 3 from the x, add 2 to the y. Does that make sense? Okay. So I was very happy with some of our justifications and realizations on 1.6. On 1.6, I saw a lot of students say, hey, the side lengths and the angle measures are the same, so they're congruent. Did any of y'all actually measure any of those angles?
No.
Did any of you ever actually measure the length of those sides?
No.
So we don't know based on that logic that they are congruent.
No.
What was done though, and this is what we want to pay attention to,
You can rotate.
it was rotated. Anybody know how much it was rotated by?
90 degrees.
Yeah, if you check it, this is 2, -4, and then it became 4, 2. The x and the y switched and went into quadrant 1, so it was just positive. So this was a 90-degree rotation clockwise? Counterclockwise, not clockwise. But why is that important? Some of us recognize that it was a rotation, but why is the fact that it's a rotation important for it being congruent? Because it's a what? It's an isometry. Which is an isometry. That's important. What's another word you could have used instead of an isometry? Started with an R. Rigid transformation. Remember that isometry is also called a rigid transformation, and the whole point is isometries create what?
Equalism.
Not equalism. Congruent figures. Or images. That is a shape. That's another word for a figure. So, I need y'all to recognize that's what I was looking for in that recognition of, hey, this is a rotation, which is an isometry, and an isometry creates congruent figures. That's important. And an isometry creates congruent figures. Dang it, y'all didn't even ask about 1.6.
I was so close.
Some of y'all did, but
I was so close.
just whatever it is. So close. It's okay that we went over it anyways?
Yeah.
Sir, what? Well, you got it wrong. Huh? Counterclockwise
Oh, everything I love. On my soul.
Hey y'all, let's continue going over these, and then you're going to get a chance to work within your small groups to get ready for the test. I will say I kind of have to go over 1.7 to get to 1.8? And I was a little hurt because way too many of us missed this scale factor. First off, to earn full credit, you got to tell me how to calculate a scale factor. How do we do it?
Image divided by the length of the image.
The image divided by the pre-image. Hey, what's the length of the image? Specifically, I guess perimeter here, right?
It's
41 points.
16.41.
What?
That is my image. Why is the 16.41 very clearly my image?
Because
it is
right
the-
there, A
It's the
prime.
prime.
B prime.
Please remember, does a dilation always make a pre-image bigger?
No.
No. Remember, when it makes it bigger, we call it a what?
Straight.
Stretch. When it makes it smaller, it's called a
Compression.
compression. But the primes very clearly tell us that this is the image. What is the pre-image?
41.03.
Does anyone have any questions about why that's supposed to be the ratio?
No.
We good on, does that make sense now that we see it? Okay? So when I do that ratio, what scale factor do I get?
Compression.
So you flipped it, right? So we need the other direction. Come on. I know some of us correctly did the 16.41 divided by 41 point, it's 0.39.
399.
399,951.
Right? So what do you think the scale factor was actually supposed to be?
0.4.
4, right? The scale factor was actually 0.4, is just rounding error. And then, first off, I want you to notice the 41.03, the 16.41, that is still the perimeter. That is not what I'm trying to do. How do I use a scale factor to get the length of each side? Not divide.
Multiply by the scale
You
factor.
multiply. Remember, you take the lengths of the pre-image and you multiply it by the scale factor. Some of us got the correct answer on 1.8 because we divided by 2.5, but you weren't supposed to divide by 2.5. With a scale factor, you always multiply. So C prime D prime is equal to 10.36. Remember, that is CD times the scale factor of 0.4. Which I don't remember that off the top of my head. But somebody? What is C prime D prime then?
C prime, D prime, that's,
Is what? There's no way. 10 times 0.4 is somewhere around 4. 4.1, does that sound right for those of us? Okay, 4.1. Does that make sense though, Ireland? Why? Okay. So I want y'all to notice, like, it had to be 10 times 0.4. Because here I was trying to get the scale factor. To get the scale factor, remember, that's a ratio of the image to the pre-image. But the way that we get the actual values is we take the pre-image and we multiply it by the scale factor to get the image. Another way to think about it is, so here's my scale factor. It's equal to the value of the image divided by the pre-image, correct? So if I wanted this image on its own, I would literally multiply by the pre-image. Because what's anything divided by itself? 0, 1. So notice if I take the pre-image and I multiply it by the scale factor, what do I get?
4.9.
So notice, like, they are very much connected, right? The way that we calculate the scale factor is to take the image and divide it by the pre-image, but that means that the lengths of the image are equal to the pre-image times the scale factor. You always multiply the scale factor times the pre-image. Yes, ma'am.
So, on number 8, you multiply the scale factor by what?
So, well, I multiplied the pre-image value CD times the scale factor. So I multiplied the pre-image times the scale factor.
I got that,
What did you get, 2.5 on 1.7? So what you probably did is you accidentally took the 10.36 and you divided by that 2.5.
where did I get 2.5?
Well, what my guess is you took that 41.03 and divided it by 16.41, but notice you did pre-image divided by image. So you flipped the scale factor. So that's actually the reciprocal of what the scale factor is supposed to be. So you had an idea with scale factor, correct, Kelsey? You just did pre-image divided by image instead of image divided by pre-image. And my guess is you knew that you were going from a bigger number to a smaller one, so you divided knowing that it had to get smaller. That's my guess. I don't know for sure.
So, I think the same answer here is 0.4 times 2.5.
Okay? So remember how you're supposed to do what with your scale factor? Multiply. So if you take 10.36 and you divide it by 2.5, I guess the cleanest way to say is that's equivalent to 10.36 times 0.4. If you want to understand that a little bit better, pick up a calculator and do 1 divided by 2.5 real quick. 1 divided by 2.5.
It's 0.4.
It's 0.4. So when you divided by 2.5, that was the same as multiplying by 0.4. Because you had, as I said earlier, it's the reciprocal of what you had. That's why. Okay? Yeah, I've gone over way more of these than I'm into, but y'all, 1.9 across the board, y'all, like 1.9 is one of those that like 90% of us should have said, hey, I don't fully know what it means to be similar. Because I want you to look at the scores you had on 1.9. 4.5 is okay.
I got 3.5.
2, I saw lots of 1s and 2s and 0s. And negative 1s on 1.9. This, both of these, I will go ahead and tell you, you should have gone to the task transformations, dilations. Both of these questions are perfectly answered there. But 1.9 is something that moving forward,